All right, so these videos are for converting from rectangular coordinates to polar and from polar to rectangular, but these are equations now. So we're going to use the same exact formula as we did before and use them to convert. So in order to convert a rectangular to a polar, a Cartesian equation to a polar equation, we will take our x and replace it with r cosine theta and our y and replace it with r sine theta. We can also do direct connect conversions. If you had x squared and y squared, we can immediately just convert it to r squared. So here our x is equal to 4. So that means that x is r cosine theta, and guess what? We now have polar coordinates. So let's look at that in Desmos. So you can see I have them both graphed. There's red, now it's gone. There's blue, and together they make purple. They are the same graph. So whether I am graphing in rectangular or polar, same exact graph. See? So there's polar, there's rectangular. So if we're in rectangular, that's the equation we use. And if we're in polar, that's the equation we use. Same exact graph. So that is it. Our job is to get rid of x and y and replace it with r and theta because those are our points. These over here are x comma y, and these are r comma theta. Neither have the other letter in them. There's no xr here. It's just r and theta. All right, so like here, if you had x squared plus y squared, you would just literally replace x squared and y squared with r squared. And there you go. So now if we take and square root it, we get r equals 1. You do want to take it all the way back. Why not positive or negative 1? Because they're the same thing. Remember, the radius of 1 and a radius of negative 1 are the same. See, here's x squared plus y squared equals 1. Sorry, that's in red. Let's put that back in red. There we go. And then in blue, it's exactly the same thing. And like I was saying, as if this was negative 1, it looks exactly the same. So whether positive 1 or negative 1, see, I'm actually changing it. In polar, remember the radius doesn't matter here because we're talking about all angles of theta. So there we go. It's a circle, see, no matter what you do. Okay, so going back, we're supposed to graph these as well. So we have x equals 4, so you would go to the 4 and you draw a vertical line. And we're going to be graphing these in rectangular because that's the way they are. But now that you know it's a radius of 1, then you could just go out 1, and I'm going to make 4 1. So that's 1, and that's negative 1, and then up 4 would be positive 1, and then down 4 is 1. And so that way I can get my circle. And then you just make a circle. So it's a radius of 1. So x squared plus y squared is a circle with a radius of 1. The radius is 1. You just write r equals 1. It's nice. It gives us a nice quick graph. So it's actually nicer to use in Desmos. Look at this. I can modify it very quickly with a slider. And I can make my radius anything I want. Okay, so we've got another one here to do. So again, x is r cosine theta. And y is r sine theta. So we're using that one now. And there we go. But you want to make this nicer. So we're gonna factor out the r. And we get 3 cosine theta minus 2 sine theta equals 6. And now if you want this for r equals, then we could say r equals 6 over 3 cosine theta minus 2 sine theta. And you can do the same thing with the first one. R is equal to 4 over cosine theta. It's your choice on the final form. I like them both. I don't like putting them in fraction form, but it is a preference. And then now we got to graph that last one. And so we're going to be using the y equals mx plus b, or we can use intercepts. In this case, we're going to be using intercepts. So we have an x-intercept of 2, 0, and a y-intercept of 0, negative 3. So there, and there, and then we graph our line. So if we check it in Desmos, both of these should give us that line. So we can see there's our line, nice and perfect. And there it is in polar. See, they match perfectly. Both are the same. So it's just a quick switch using what we've been using. So rectangular, polar, both the same. And there you go. And so solving for r is the standard. People like to solve for r, but I like to keep it on one line, not fraction. So preference. Okay. Now we're going to be converting back.